So how can we actually test wireless microphones, transmitters, and stuff? Well, unless you have another receiver to verify it works or doesn't work, or the problem relies with one or the other, the only real way to actually see what's going on is going to have to be spectral or some type of modulation analyzer or communication set analyzer that can look at an RF spectrum. And without this stuff, you really are left to just trying it with another piece of equipment. So what we're actually looking at here today is a Samson, let me see, R32M, which is a UHF FM transmitter, mic, and receiver. Actually, the microphone is actually a different model. The model that I'm speaking to, the R32M, is going to be this receiver unit here, which it does have dual antennas. So depending on you're on one stage side or the other, he will show antenna A or antenna B. And as you can see, we do have good RF going on here. So what the actual customer concern was is that after a few minutes here, this thing would lose volume, and he'd have to try to turn up the little potentiometer inside of here, and he still just wouldn't get enough gain. So we verified that, boom, yeah, you go to turn this thing on, and it'll work, and then all of a sudden it just stops working. And what I noticed is that A works just fine. Antenna B loses everything. So unfortunately, with stuff like this, not having any real schematics, service information, you're kind of left with your knowledge of past stuff you've worked on. And if you've never worked on stuff like this, any radios, communication sets, stuff like that, you're going to be at a loss, and this is not going to be anything that you really want to dive into. But we can hack this guy. We can get him at least working and stop flipping antenna A and antenna B. Our failure in here, what I lead to believe with a little bit of diagnostic that I've done, is discriminator here is just not functioning. We're not getting a nice clear-cut signal. So we do have a bunch of trimmers, little itty-bitty guys that have been here. We can try to see those guys right there. VR2, VR1. We got them over here, over there, and what we can point out right away is we do know that this is our oscillator. This right here is a variable capacitor. As you can see, the trim pot looks a lot different than these little guys. So we do know that is oscillator, our reference point. This is a PLL synthesized with automatic switching between antenna A and antenna A and antenna B. No, I got it backwards again. This is upside down. Antenna A is on this side because we're upside down. As you can see, marked right there, A and B. So he synthesized, we're on frequency. I was able to check a couple things. He uses 10.7 megahertz, very common type oscillator. We've got a couple filters. We can see 1, 2, 3, and 4, these yellow guys. So these are not capacitors. They're three-legged. They might look like a capacitor. They are not capacitors. So anyways, just, pinpointing a couple of frequencies and comparing, because this is an image, okay? What is here on the right side is the same things on the left side up until a point, and then we have some other stuff going on here. But as far as the switching between A and B, it would want to keep going to B. It doesn't matter if I stayed on the right side of this thing, the left side of this thing, kept wanting to go to B. And that's a problem because B antenna, or B side, is giving us the issue. Well, after digging out a couple things, tuning up this guy to get the strongest signal, still left me with the same thing. So there's only a few other things I could do, and I just verified a couple voltages and pinouts from this side to this side, and everything looks pretty much the same within, say, 5% of stuff. So we're left with most likely a failure to one of these parts, and these guys are just too cheap. You can get these things used for like $30, so it doesn't make sense for me to charge the customer to replace a component in here when it's going to be over the price of just replacing this with a used one that's working. So what we can do, though, is we can say, let's fool this guy a little bit. very simple, very easy. If you do have an issue like this with, say, a dual antenna type setup and one side's just not working, and you're not using really anything except for one microphone or one transmitter, what we can do is just disconnect the antenna, and that's pretty much all that we've done here. As you can see on this side here, our flying lead, let me see if I can get this in focus for you. Our flying lead right there, he's not connected to the pad anymore, compared to this side where he is. So now, when I go ahead and hello, testicle, 1 2 3 4, audio, check. So yeah, all that that stuff is working all good now, and it doesn't keep switching. But this isn't a real repair. This is just, we're gonna hack it to work. It's gonna do its job. I tested it out for a few hours, and he's still okay. But how could I have verified any of this stuff was good if maybe the problem relied with our transmitter? And that's where it comes into stuff like that, and that, and that. So without having another one of these, you're really going to be at a loss. Some type of receiver module that you could listen to it or look at it. So this guy up over here, I can listen to it, I can look at it, I can transmit into this guy, making sure all of this is working, and it does. It's all working like it should, except for antenna B. I'm getting the RF, it's showing the RF, okay? That's the thing we gotta have to make clear here. On antenna A and B, the RF signal is showing high. So my most likely scenario is discriminator, getting the audio back out of it. It's just not pushing it up enough. Everything else has looked good. I test a bunch of the coupling caps around there. Everything's still good. So, but how would I have known my transmitter's good? Maybe it was just a crappy microphone or something like that. And that's where it comes down to stuff like this. So as you can see, audio, check, audio. You see it bouncing around there. And that's going to be because we're FM modulated. An AM modulated signal, our audio would be transmitted in amplitude, where in FM audio, check, we're getting left to right, which is our frequency, our span. So just showing you a little bit there. Stuff like this is at least to say is expensive, and unless you just like playing around with stuff, then that's probably not a gift you're going to be asking for Christmas for. The other stuff here, you know, this guy right here, he's an RF generator up to a, I think, what the hell is he up to? I think a gigahertz? Yeah, I think so. 900 megahertz or something, 9.9 megahertz. No, not 9.9. God, I can't even remember what the hell they were. 990 megahertz, that's what it was, almost up to a gigahertz. And then this guy here is a receiver, and he can demodulate. You got all your FM de-emphasize, filters, measurements for how strong of a signal we got. So basically this is a real cut down version, these two, of what is all in our communications analyzer. The spectrum analyzer that is built into here is very basic. It doesn't really give you any correlation of signals, of comparing stuff, except for what is on our actual grid here. So that's where something like this obviously comes into much more handier. So we can actually zero span this guy and look at our audio signal. Audio, check, audio, check. Audio. So we're actually looking at the audio signal there, which, yeah, it's working. So let's go back, let's do a span of 100 kilohertz again. And there we go. So there's our signal. Check, audio. And yeah, turning him back off and on, and he is coming back on every time, because what would happen, what was actually happening is that you turn this guy on and he'd be fine. You go to turn the mic off and back on, he would keep switching to B. And that was why it would work in the beginning, and then, you know, a few minutes later it would find it, you know, maybe you were stronger on the B side, and it would switch to there. We don't want the B side working anymore. We're just going to use A. This is honestly the cheapest and easiest way to get this guy usable again. But would I really honestly want to charge a customer to repair this thing correctly? Just in the diagnostic work of pinning out stuff and finding and, you know, pinpointing it out is going to be 3 times more expensive or more than buying a used one of these. So that's where you gotta cut your losses sometimes and explain to customers that it is not economical to repair it. Unless this was some type of special deal, they only made 5 of them, that's where it's worth fixing. The rest of the stuff, cut your losses, throw it in the bin. Anyways, hope you enjoyed this little video here. Like to bring whatever I can up onto the YouTubers and get to check out what the hell's going on up in here. Anyways, catch you next time.